All right, this video is going to be defining and evaluating functions. So, first we want to look at what is a function. So, a function is a relationship between two values such that each input has exactly one output. So you guys have seen functions before. Some examples are polynomial graphs. They just kind of look curvy. Like that's an example of a function. Each input has exactly one output. You might remember the vertical line test. So examples, you might write this, they pass the vertical line test. Another example of a function would be a parabola. It passes the vertical line test. Another example of a function would be y equals x squared. That's just the equation of the picture of a parabola. So we can say functions are graphs that you can see, but they're also equations that would give you those graphs that pass the vertical line test. Y equals the square root of x is an example of a function. Here's another example of a function. We can use tables. So if -3 gives you 2, and 4 gives you 1, and 7 gives you 1. So a function is going to give you a predictable value. Every single time you plug in 4, you're going to get 1. There's no question that's the answer you're going to get. All right. Some non-examples might be kind of helpful so you can really see what's going on here. So a non-example of a function is a circle. We have this x value, let's say that has an x value of 2. Down here, this also has an x value of 2, and it's not predictable. When I plug in 2, I don't know if I'm going to get this positive y value up here or this negative y value down here. So that is not a function. It does not give me each input, the input 2, does not give me a predictable output. It could give me one or the other. Another example, or non-example, of a function, something that is not a function, is a sideways parabola. So this is kind of like if you were to take the equation y equals x squared and you were to solve it for the x, you would get y equals positive and negative square root of x. So the top is the positive square root of x, the bottom is the negative square root of x, and so we're going to say you could plug in 2, again, we could plug in an x value of 2, and our answer is not predictable. We could get the positive version, we could get the negative version, we're not sure which one we're going to get each time we plug it in. Another example here, we could look at a table. Let's say we plug in -3, we get 1, then we plug in -2 and we get 5, and then we plug in -3 and we get 6. Again, this is not a function because our output is not predictable. I could get 1 or I could get 6 for plugging in -3, and I'm not sure which one I'm going to get. Right? So that's the difference between a function and something that is not a function. Typically, when we write functions, we write something, in the past we've written a function as y equals an equation, and that's what our function is. Now we have a different type of notation, and actually maybe we should give this a heading. You don't have to erase it if you wrote in pen, but I'm going to go ahead and write the notation for this. Y equals something is what you've done in the past. Now we're going to look at function notation, which is f of x. So what this is, when you'd have some sort of equation, we read this out loud saying f of x. It means you plug x in, and that's how you get the y value. That's what it actually means. All right, so let's think about some evaluating that we've done in the past. In the past, you might have an equation like y equals 3x plus 2. And they might tell you something like find y when x equals 5. So then you would say, all right, y equals 3 times 5 plus 2. And then you'd say, okay, when x equals 5, my y value is 15 plus 2, so my y value is 17. So when I plug in 5, I get 17. With the function notation that we're going to be using now, instead of saying y equals 3x plus 2, we would say f of x equals 3x plus 2. And what this means is it means a function in terms of x. That's what f of x stands for. So a function that's written in terms of x. So instead of saying find y when x equals 5, they're going to say find f of 5. So that means find the function when you plug 5 in. So to do that, we would say f of 5 equals, so I can see that there was an x here, so I put a 5 in for it, and then 3 times 5 plus 2. So I'm doing the math exactly the same, I just have f of 5 instead of y. And then my final answer would be f of 5 equals 17. So the cool thing about function notation is it says if you plug in 5, you get 17, instead of this where it just says the answer is 17. It kind of tells you what you plugged in to get an answer out of it. Now, there's another type of evaluating we might do. So this right here, what we're doing right here is evaluating. There's another type we might do where we're evaluating but not necessarily for a number. You might be evaluating for a letter or for an expression. So we're going to go ahead and look at f of x equals negative x squared plus 2 over x plus the absolute value of x. And we're going to evaluate this. We'll do it 2 or 3 different ways. I'll see how long the video is getting. So first, let's go ahead and find f of negative 3. So that means that everywhere I see an x, I'm going to plug a negative 3 in. So I'm going to do 2 of negative 3 squared plus 2 over negative 3 plus the absolute value of negative 3. And when you do this, when we do these evaluating problems, you can plug it straight into your calculator if you want. You can do it in your head if you want. So I'm going to go ahead and plug it in my calculator. And you can see that when I plug it in, the answer I get here is negative 20/3. I could also say, let's go ahead and evaluate for 2k. So if I was to do that, then every place that I see an x, I would put a 2k instead. So for this, I got to do a little bit of simplifying here. I can see this is negative. 2k times 2k is 4k squared. 2 divided by 2k, those 2's are going to cancel out. So I just get 1 over k, and then the absolute value of 2k is going to have to stay as the absolute value of 2k. And then this would be my answer if that's what I plugged in. So sometimes we plug in a number and we get a number answer. Sometimes we evaluate a function for an expression and then we get an expression as the answer.